Okay. Are you there? Jaswant, are you there?
Yes, ma'am.
Hello.
Yes, ma'am. Yes, ma'am. I can hear.
Fine.
Yes.
Actually, yesterday I have explained her about, means even one girl was there with you, I guess. What's her name? Shreyasi. I don't know why she didn't join today. I explained about the long form of periodic table. I hope you were there that time. If not, then I'll just revise the things. Okay. The nomenclature
Oh,
things. Okay.
okay, ma'am.
Fine.
Okay.
Fine. So about Mendeleev, we have learned its importance also we have learned, isn't it? Mendeleev periodic table, right? I told you about there would be the horizontal rows and the vertical column in the Mendeleev's periodic table, right? And these horizontal rows he named as a series. You were there when I told this, right? And
Yes, ma'am.
vertical columns of the Mendeleev called as, right? But then when we come to the long form of periodic table, in this case, what happened? The horizontal row is called as what? Periods. Okay. And vertical column is called same as a groups in the long form of periodic table. So what is the basic difference in between Mendeleev periodic table and the modern periodic table? The difference is there would be 18 groups. How many? 18 groups in the modern table, right? And it is based on atomic number. Okay. The basic fundamental property is nothing but atomic number. Correct? Why it is so? When Henry Moseley he plot a graph of velocity of X-ray with the velocity of X-ray. He plotted against what? The marks made by the emitted rays. Okay. We got what? Straight line graph. But then same velocity when plotted with the atomic mass, graph wasn't be straight line. When velocity we plotted with the atomic number of element, we got the graph straight line, right? And when we plot the root of velocity versus atomic mass, that time it won't be straight line. And hence, what we know, atomic number is a more basic and the fundamental property. Fine. And hence, what we have done, we have chosen the atomic number as a basic fundamental property. And on the basis of that, in increasing order of atomic number, we have, not we, Henry Moseley arrange all the known elements that time. Okay. And hence we come to know about the modern periodic table. Okay. So in that modern periodic table, there would be the horizontal rows that are called as the periods and the vertical like lines that are called as the groups. Like that, how many? There would be 7 periods and 18 groups and periodic table. Okay, fine. Among these 18 groups, in each and every group, the elements those are present, they have a similar properties. What they have? Similar properties, right? And the number of period, how many? 7. And each period have the different number of elements. First period have 2 elements. Okay. Then the second period have second and third period. Both they have 8 elements each. Okay. Fourth and fifth period have 18 elements each. And then sixth period have maximum number of elements, that is 32 elements. And seventh period is incomplete period. Seventh period is what? Incomplete period. Correct? Got it? Yes? Jaswant, are you there?
Yes, ma'am. Ma'am,
You have to respond on time, okay? Because if I
yes,
asked
ma'am.
you something, if you want to revert me back, I won't understand whether you're there with me or not. It should not happen like I'm only babbling from my side and you're not paying any sort of attention. It won't be fruitful, isn't it? Fine. Now we are going to go to the nomenclature section. Excuse me. Okay. So one chart is given to you for the nomenclature. And even we are going to discuss the modern periodic table when where you were not there. Correct? Fine. This is the modern periodic table. Yeah, a simple 5 minutes topic is there that I'll explain you once, and then we'll go to the electronic configuration in periods. Okay. So you can see this question, problem 3.1. You were not there. Okay. See the question, what is given to you. What would be the IUPAC name of symbol for the element with the atomic number 120? What is the atomic number is given to you? 120. Correct? Yes or no?
Yes, ma'am.
Why this problem occur, in America and at the Soviet. Okay. And the Soviet, they have found one element which has an atomic mass 104. America labeled this element as a Rutherfordium and Soviet labeled it as a some of the other name. It's quite complicated name, so I cannot recapitulate it immediately, but then it was different name. But then atomic number of the element is same, right? That is 104. So there was a problem. Which one is to be considered, whether Rutherfordium or other name which has been suggested by the Soviet scientists. And hence IUPAC suggested that whenever there would be a new element has been formed or discovered, that time that time one should be have to do what? Yes, one should be decide the name on the basis of IUPAC nomenclature, right? IUPAC nomenclature. And what is that? How you have to nomenclate it? See, this is the chart which is given to you. On the basis of that chart, you should do this. Where is that chart went? Yeah, this one. Fine. Are you able to see this?
Ma'am, yes, yes.
Yeah,
Yes, ma'am.
yeah, fine. So see, the other name, what I said, that was here only, it's given to you. The name is Purchatorium. Okay. And the first name is what? Rutherfordium for the element which has the atomic number 100. Right. If 0 is there in the atomic number, then you have to use the term nil. If 1 would be there, that time you have to use the term un. If 2 is a term, that time you have to use bi. If 3, that time you have to use pri. For the 4, it would be quad. For 5, it would be pent. For 6, it would be hex. For 7, it would be sept. For 8, it would be oct. And 9, it would be n. Okay, like that, several elements nomenclature is already given. And later, IUPAC gave the confirmation for the proper name, which it should be given. Right? I'll let you know how. See here. Fine. Fine. Unilium, how it will become? The number would be what? 101. 101. So for one, what we have to use? Un, correct? Yes, just one. Are you there with me?
Yes, ma'am.
Yeah. For one, it would be un. For the zero, it would be what? Nil. Correct? Yes. And
Yeah, yeah.
again, for the one, it would be un.
Un.
Un, nil, un. And niyam. Means IUM, you have to add after it. So this would be the name for 101 atomic number. Okay, as per the IUPAC nomenclature. And the abbreviation would be UNU. U from un, right? Then N from nil and U from un. So it would be U, N, U. Got it? Fine. Then later when IUPAC officially named it as a Mendelevium. Okay, and the IUPAC symbol is given as a MD. But then earlier, whenever it is formed, that time the name would be given as per the IUPAC label. So what would be the for 120? Can you give name for it? Which was asked
Man,
into the problem.
Anbium.
What? Un,
Anibium.
un by, by means,
Anbium.
oh, sorry. Un by means for two. No? For two, what you
Yes,
have
ma'am.
given?
By.
By. And zero, nil,
Nil.
yum.
Okay.
Right?
Yes, ma'am.
Okay. Understood? Clear?
Yes.
We'll check
Yes,
that
ma'am.
whatever we have given, that's true or not. Fine. Clear? See?
Yes, yes, ma'am.
Yeah. Unbilium. See here, it is the name. Got it? And the abbreviation would be UBN. Yeah?
Yes, ma'am.
Okay. Now see what is further given to you. We have to discuss the terms present into the modern periodic table. In that, the very first point which we are supposed to learn, that would be the group-wise electronic configuration. Here they give electronic configuration of elements and the periodic table. And on the basis of electronic configuration, how periodic table has been classified. Correct? So what is given to you in this? In the preceding unit, we have learned that electron in the atom is characterized by the set of 4 quantum numbers, right? And the principal quantum number is what? N, which defines what? N defines what? How many energy levels present into the atom. Okay?
1, 2, 3,
1,
4.
2, 3, 4, 5, 6. That
Yeah.
is the number of shells present in an atom. So we have also studied about the filling of electron into different orbital. You know that rule? SPDF.
Yeah. Yeah, ma'am. Yes. PDF.
Understood. How many electrons should be fixed into the S?
2.
S can occupy 2. P can occupy 6. D can
6.
occupy
8.
10. And
10.
F can occupy 14. Correct?
Yeah. Yes, ma'am.
Yes or no?
Yes.
Are you aware about it? If not, then please make a note of it. S orbital can be occupied only 2 electrons. P orbital can be occupied 6 electrons. D orbital can be occupied 10 electrons. And F orbital can be occupied 14 electrons. Okay. Now, these orbitals in an atom is distributed the electrons into orbitals of an atom called as the electronic configuration. Means the electron present in an atom, when you distribute in the orbitals like SPDF, that is called as the electronic configuration, right? So in that, what they have given you, the first point, see electronic configuration in periods. Periods means what? The horizontal rows, correct? These horizontal rows in the long form of periodic table is called as a period. Correct? Yes or no? So how it will be vary when you move from left to right, that we have to check. Okay. The period indicate the value of n for the outermost of the valence shell. In the other words, successive period in the periodic table is associated with filling the next higher principal energy level. Means n is equal to 1, n is equal to 2, etc. Now, how does it valid? Whether it is valid or not, that too we need to check. Fine. For that reason, we will move here at the periodic table. Fine. You can see this periodic table in this. The first period consists only two elements. One would be hydrogen, other would be helium. Right? Here it is hydrogen. Wait a minute. I'll share the vertical table with you, so that would be more convenient to understand. Fine. Give me a while. Video. Okay. Okay. Just one, I'll share the same picture. Okay. Actually, currently, I think it's not available with me. Then whatever available, that I'll share with you. Okay. I hope you'll understand. And if you have any problem, then let me know. Means like if you not understood any concept, please tell me so I can repeat it. Okay. So in the first period, there would be only two elements, that is a hydrogen and the helium, correct? Yes or no? Have you gone through the periodic table?
Yes, ma'am.
Is it there with you? I asked you to download it, right? Hydrogen and helium. Jaswant, are you there with me? Hello?
Yes, ma'am. I have the
What
period.
happened?
Yes.
Sorry?
Ma'am, I just downloaded it.
Okay, fine. Now, yeah, please download. So you will come to know in the first period, there would be only two elements, right? So the number of period indicate the number of energy level which is filled in that particular period. For the first, if you can see hydrogen, it has only one shell, isn't it? Hydrogen, it has one proton in its nucleus. Then the neutron, hydrogen is the only element which does not carry any sort of neutron in its nucleus, and only one electron would be revolved around the proton, isn't it? So this is about hydrogen. And the second element in the same period would be helium, which consists what? Two proton, okay, two neutron in the nucleus, and two electrons would be revolved, right? Means the first energy level, which has a capacity to hold only two electrons, okay, and that two electrons only would be filled into the first period when you move left to right in the periodic table. Understand? And same thing is happened for the next period, second period. If you go right, the numbers you can check: lithium, beryllium, then the boron, right? After that, you can see here boron, carbon, nitrogen, oxygen, fluorine, and neon, right? So these, how many? 8 elements are there. How many elements are there? 8 elements. And these elements are filled into the second shell, isn't it? Yes or no? Fine. For your understanding, I'll write it here, all the elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And after fluorine, there would be neon, right? Yes or no?
Yes, ma'am.
Yeah.
Yes, ma'am. Yeah.
So these are what? Second period, correct? Yeah. So in this, what happened in lithium, you can check. Lithium atomic number is 3. So it consists 3 proton, correct? 3 neutron or maybe 4 neutron, right? In the first shell capacity, it must consist only 2 electrons. And the second shell, how many electrons would be moved? 1 electron. Means when you move left to right in the period, your shell is start to fill up, and at the end of period, it will be completely filled, right? Means for the lithium, atomic number is 3. So here 1 electron would come. For the beryllium, atomic number is 4. So here 2 electron would come. Then for the boron, 5 electrons would be there. Atomic number is 5. So atomic number is equal to number of protons, and number of proton is equal to number of electrons. So for the boron, if atomic number is 5, then the number of electron is also 5. So it will be 2 and 5. Sorry, 2 and 3. Total it would be 5, right? When you go to the carbon, what happened? It become 4 electrons. When you go to the nitrogen, it becomes 5 electrons. Isn't it?
Yes,
Yes?
ma'am.
Yes. So what happened when you move left to right in the period in a long form of periodic table, one new shell energy level start to fill up, and at the end of period, it will be completely filled. If you see about the neon, see for the neon, it's the last element into the second period. Its neon has an atomic number 10 and it has electronic configuration 2,
2,8.
8. Means 2 electron would be present into your K shell and 8 electron would be into your, which one? L shell. And the maximum capacity of the second shell to hold the number of
8.
electrons is 8. Right? Isn't it? And
Yeah.
it is completely filled. So what you come to know by this? The rule, when we move in a periodic table left to right, new energy shell start to fill up. Which energy shell will start to fill up? The number of period
Down.
is
Yeah.
nothing. The number of period is nothing but the number of shell, which is start to fill, right? And at the end of period, it will be filled completely. Okay?
Okay.
Understood?
Yeah.
Fine.
Yes, ma'am.
The same thing for all the periods. I need to explain it now or you understood? I need to explain all the periods at a time or you understood the concept what I tried to tell you. Just what I'm asking you, beta.
Ma'am.
Hello.
Yes, ma'am. I can. Yes.
Fine. Okay. We'll move forward then. See what else given to you. Here, what is given to you in this, the next point about the electronic configuration. We have seen the electronic configuration in a period. Fine. So what is given over here? Same thing which I have explained. Transition series about it also, they have given you something that I'll just, so that will be thoroughly clear to you. You can check it out here. Okay. So what is given here in L shell? Completed at a neon. Just now I have explained you about it. 2s2, 2p6, correct? Yes or no? Yeah. 1s2, 2s2, 2p6. Like this, you are going to fill it, right? This is for neon,
Yeah.
isn't it?
Yes. Yes, ma'am.
Yeah. So total number of electron in this what? 2 and 2, 4 and 6 total it is 10, right? So there are the 8 elements in the second period and the third period n is equal to 3. Which energy level is start to fill into the third period? Third, right? It begins with sodium, correct? Yes or no?
Yes, 11. Yes.
Sodium
Yes, ma'am.
atomic number is what? 11. So its electronic configuration, how it will be coming? If normally if you write that
281.
will be 2, 1, correct? So third energy level start to fill. And if in this manner you're going to write, it will become what? 1s2, 2s2, 2p6 and 3s1, isn't it? Yeah? Yes or no?
Ma'am, can you explain how to do in this manner, like 1s2,
Which one
2s2?
beta?
I think I'm not sure.
Which one?
How to express the.
Means writing of electronic configuration you're not
Yes.
understanding.
Yes, ma'am.
Okay,
Ma'am, in
okay. Means this via this rule you're not understanding. Means you are
yes,
aware
PDF.
of
Yes.
K and L, M, N shells.
Yes.
According to that, you're aware, but then you're not aware about the Huckel's principle, right?
Yes. Yes, ma'am.
Fine. Okay,
I'm not clear about it.
fine. I'll explain you. No issues. Here you can see how you have to fill it. 1s2, 2s2, 2p6. In this sequence in this number sequentially, you have to fill the orbital. Keep it in your mind. S orbital will be filled first, right? Then p orbital will be filled. Then d orbital will be filled. And and then f orbital. This is the sequence. In this way, you have to fill the orbitals present in an atom. Correct? Yes or no? Now, how many energy levels are there in each and every shell? In that way, for this, S would be, suppose I have to fill for the sodium. Just now I have explained you, 1s2. S orbital consists only two elements. Its capacity is to holding only two electrons. I'm sorry, it won't be element, it would be electrons. P orbital has a capacity to hold 6 electrons. D orbital has a capacity to hold 10 electrons. And F orbital has a capacity to hold 14
14.
electrons. Right?
Yes,
Now,
yes.
yeah, the way how you supposed to fill the electrons, that too I'll show you way. Wait a minute. Yeah, I'm going to stop sharing this. I'll share you the image, the way how you're supposed to fill the electrons. Okay, it's been need to be minimized, so it would be open in Windows. Just one thought about the students which were there with you earlier. Has been suspended or what? I couldn't see them.
Ma'am, they
Since last
joined. They were joining, like not every class, but some classes.
only few classes they were joining.
Yes, yes, ma'am.
Okay, because I got to know somewhere they have suspended. It's like for chemistry they are not joining, only maths they are joining or what?
I don't know about.
Okay, whatever it would be. Hmm? Okay, no issues. Because today only you are there. Yesterday at least one girl was there, Shreyasi, right? Okay, you can see this sequence. What you have to do, beta? First of all, you have to write the all s orbitals. 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, right? Then after 2s directly you have to write 2p because 1s orbital doesn't have the p shell. Okay? So 2p, 3p, 4p, 5p, 6p, 7p you have to write, right? Then second shell doesn't have the d orbital and hence you have to start it from the third orbital, third shell. That is 3d, 4d, 5d, 6d, right? And fourth shell doesn't have the F, so it doesn't have any other F onwards. Up to by F only it has, and hence you have to add over here 4F and the 5F for the fifth shell. Fine. You can add furthermore, but then for understanding it is easy. So in that way only I'll explain you. Fine. What you have to do in this, you have to move in the zigzag manner. I'll show you by the annotation. You can check this. In this way, from 1S, if you started, you have 1S, you will go to the 2S. After 2S, you're going to go to the 2P. From 2P, again, you'll get to 3S first. You won't go to 3P directly, okay? 3S, then 3P, then 4S, then from 4S again 3D. 3D will 4S will fill first after 3P, and then the 3D will fill because the energy of third 3D orbital is more as compared to 4S orbital. Because of that, it happens. Okay. And from 3D again, it will go to the 4P. Correct? From 4P, it will go to the 5S. And again, it will go to what? 4D. In the same manner, in this sequence, it will work. Fine. Understood? Or still not understood?
Understood. Understood.
You take a screenshot of it, and same thing, you have to write it on a paper, practice it well, and then definitely you're able to do this. Now, what you have to do, like you have to follow same for this sodium, right? I hope you have taken the screenshot.
Yes, ma'am, I took.
Number of electrons would be 11, right? So it will go what again? 1s2, then 2s2, 2p6, then 3s, 1. So you can check 2 and 2, 4, and then 6, how many? 10. And after 10, it will be what? 1, 11, isn't it? So s orbital have how many electrons? Only 1. Correct? Yes or no? So 3s orbital would be filled successfully. Successive filling of 3s and 3p orbital give rise to the third period and 8 element of the sodium to argon. These elements are from where to where? Sodium to argon. Correct? And the fourth period would be N is equal to 4. Start with the potassium and added electron to 4s orbital onwards. Correct? So you may note that before 4p orbital is filled, filling up 3d orbital becomes energetically favorable. Why? Because 3d orbital require less energy as compared to 4s. Got it? Yes or no? These elements are called as transition. These are transition series, and from transition series only d orbital will be start. D orbital will not be present into p block or even to the s block or s block elements. And yes or no? P block and s block elements are there in your periodic table. It does not have d orbitals inside it. I'll let you know how. Check this. You can see this blue line. Yeah.
Yeah, yeah.
These blue bars, are you able to see in a periodic table? These are what?
Yes, ma'am.
S block elements.
S block.
Yeah. Right. It does not have d orbital in that. If you move forward, you will check this. These are what? P block elements. From boron onwards. These are what? P block elements. Right? These are also doesn't have a d block elements. Sorry, d orbitals inside it. It does not have what? D orbitals inside it. Fine. But then if you see these elements from scandium to what? Zinc. Right? These are transition metals. These are called what? Transition metals. Right? And these transition metals have d orbitals inside it. These transition metals have what?
D orbitals.
D orbitals inside it. Yes. These are transition metals. and it has d orbital. And to keep in your mind this sequence, I gave you one slogan yesterday. You were not there, so I repeat it. That was Stati Vakramana Feko Nikunja. So what I said, you might be it might be sound like a Sanskrit shloka or something, but then it's not like that. Stati, for the sk, it would be scandium. For T, it would be titanium. Vakra, for the V, it is vanadium. Kra means for the chromium. Vakra, mana, manganese, and Peko means ferrous. Ko, cobalt. Ni, nickel. Kunda, Cu, copper, and Zn. Correct? So you can see this series. Are you able to see? Skati Vakramana Peko Nikunja. This is the first transition series. What is this? First
Transitional series. First transition.
transition. This way you have to keep it in your mind. Skati Vakramana Peko Nikunja. And these orbitals have d, or these elements have d orbitals inside it. Right? These elements have d orbitals inside it. Fine.
Yes, ma'am.
Yes or no? Now, when you go for the group, only a few things I'll explain you about the electronic configuration of a group. Number of elements present into the group, number of elements present into the group, how many it would be, it doesn't matter. But then electronic configuration, the outermost electronic configuration of all the elements is same in a group, right? Outermost electronic configuration is same in one group. Fine. Understood or not?
Yes, ma'am.
I'll give you example in tomorrow's period, and then I have to take some questions, numericals on the basis of this knowledge. So tomorrow we will discuss it directly, and few I'll post that you go through. Have you seen yesterday's questions or not? Yes,
Yes.
that's all. Have you seen yesterday's questions
Yes,
or
ma'am. I
not?
have seen it.
Have you seen?
Yeah.
Okay.
Yes, ma'am.
Solved or not?
Ma'am. No, ma'am. Ma'am.
Why you are only seen? What is the use of it? Now I'll do one thing. I'll post it to you privately or text me. Okay? And try to
Ma'am.
solve it. Yeah, please speak up.
Yes. I have it in.
Speak,
No, ma'am.
speak loudly. I'm not able to hear you.
Ma'am,
Yes?
in WhatsApp. Where, where can you post it, ma'am?
Yeah, yeah,
Like
on WhatsApp, on
on the
WhatsApp.
app or okay. Okay, ma'am.
On WhatsApp, on WhatsApp.
Okay, ma'am.
Okay? Yeah, I'll post it. I'll post to you, and please go through it and try to solve it. And even app, I'm going to upload it. Fine. So today's question I'll upload in an app, and yesterday's I'll post to you. Okay?
Yes, ma'am.
Yeah. And tomorrow, without fail, on same time you should join. I don't know about others, but then you should be there. Okay?
Okay, ma'am.